Okay, here we go. All right, 74, 75, any of those you want to go over? Any on these? This was talking about the transformations, the shifting up and down, right and left, right? Correct. Any questions you want me to go over? Get phones away, please. Phones away, please. You're okay with things shifting up, down, right, left, reflecting over the x and the y axis? Help me out on what you're trying to say. Well, I'm going to actually hit on that in the first part of this lecture, and I think, tell me if I didn't answer your question, but I think I would be able to answer it. Anybody? Any of the questions? Yeah? No? 107, sure. All right, problem number 107, we have g at x is equal to negative 2 function at x. Okay, so it says the graph y equals function at x follows. No formula for f is given in exercise 107 to 114 graph the given equation. Okay, negative 2f at x. Okay, so they give you this equation. That's basically the equation they tell you, saying this equation is function at x. So they want you to modify that in order to justify what g at x is equal to. Okay? I guess I could put the points. So this is going to be the point negative 4, 0. This is the point negative 3, negative 2. This is the point negative 1, negative 2. This is the point 0, 0. This is the point 2, 3. And this is the point 5, 0. And I don't have the xy axis in there, which I think will be fine. So first thing we're going to do, it's going to be a taller graph, that are both in the positive and negative infinity range. Okay, so it's going to be taller. And then it's also going to be flipped over. Okay, so the x value itself isn't going to change on these. The y component is going to change. So, it's -4, 0. So this point here is actually going to stay there as this. This point, this is going to change. It's going to go to negative 4, but it's going to be negative. So then this point is actually going to come up here. So this will be the point negative 3, positive 4. Okay? Then this is going to change here. So that's going to move up. It's still going to be negative 1, but it'll be at negative 1, positive 4. 0, 0 is still going to remain at 0, 0. And then 2, 3. So it's going to go to 6, but it's going to change. So this is going to become 2, negative 6. And this point will still stay on there. So let's graph it. This is going to come up, over, down, down, and up. Was there a question? Okay, so this didn't change the x direction at all. It just changed how tall it was as well as flipping it over. What else do we got? We good? Going once? Going twice? All right, if you got a top mark or any old homework assignments, pass them on forward and on down, please. Our plan this week is as follows. Today I'm going to go over a little bit of what we had done last week, and then also going to talk about symmetry, things called even and odd functions. Tomorrow we're going to do a review, so if you could have a textbook or at least take a picture of the pages of the review so we can use it on the phone. Wednesday we will have a good amount of time to go over the review of anything that we might not have covered. Also on Monday we will take the non-calculator portion of the test, but please remember the non-calculator portion means this about the calculator. You can have the 4-function calculator, okay? You just can't have the graphing calculator on this portion. So the one that adds, subtracts, multiplies, and divides is totally fine. If you don't have it, go through mom and dad's for Wednesday, I'm sorry. Today's Monday, right? And then on Thursday we'll take the remaining portion, and then Friday I heard a pretty good rumor that you guys should continue to spread. There's no school for you guys. I think that's a good rumor. I keep spreading it because we continue to spread a rumor, it becomes the truth, right? Yep. Perfect. Hey! Thank you very little. Thanks. All right. Thank you very little. Anyone know what movie that came from? Caddyshack. Thought you guys might like it. All right. Shh. I want to graph this graph. Is that okay? Can I graph this graph? So what's my y-intercept of this graph? -2. Everyone okay with that? So that's the point 0, -2. Still with me? And the slope of that is I'm going to go up 3. 1, 2, 3, and over 1. So this is now the point 1, 1. So this graph is going to look like that. Seem okay so far? If I wanted to shift the whole graph up 7, what's changing? X or Y? Y. Okay, so let's take care of this. Let's shift this whole graph up 7. So this is going to go from -2, so I'm going to shift up 1, 2, 3, 4, 5, 6, 7. So that's up 1, 2, 3, 4, 5. So I'm up 0, 5. What about this point? What's going to change? X or Y in here? Y. 1, 2, 3, 4, 5, 6, 7. So this is still going to be the point 1, comma 1, 2, 3, 4, 5, 6. Is that 8? 1, comma 8. So if it shifted up 7, pretty simple. What about if it shifted left 6? What's going to change? X. So the X, I'm going to go back to the original. Do this one in blue. We're going to shift left 6. The X is going to change. So this is going to get to what point? -6. So 1, 2, 3, 4, 5, -6. -6, 2 is right here. And then this point here is going to change. So I'm going to come back. 1, 2, 3, 4, 5, 6. So that will be the point. So this is the point -6, -2. And this right here is the point, excuse me. Is that the point? -5, 1. Okay? But then, what happens if the graph itself does a stretch? Linear stinks for stretch. Because a line stays a line stays a line. So if you stretch a line, it still just looks like a line. But the stretch in this case is I'm going to multiply all of the original y values by 2. So I'm going to go to 0, -4. Oh, excuse me. We're doing this stretch by -2. So I'm going to flip it. So I'm going to go 0, 4. And then this one's going to become 1, -2. So 1, -2. So the negative flip-flops it, as well as changes the pitch of the line. I don't want to say it changes the slope of the line, because obviously if you become an opposite slope, the slope's going to flip over. So it's not a perpendicular slope, but it just changes what the pitch of the line or the steepness of the line. Okay? God bless you. So let's move on and let's talk about. Do you need me to go back? I just want to see what the book is going to say on this. Okay. I don't want you to write too much down. I want you to watch right now. See if we can figure this out. I'm going to use a parabola. Is that okay? Let's have the parabola be this. So I'm going to use functional notation. Let's have it be x squared plus 4x minus 7. So if you were to look at this and you wanted to graph it, you could easily graph it. You could use the negative b over 2a to get the x component of the vertex, plug that back in to find the y component of the vertex. But if I wanted to determine if this was an even or an odd function, I'm going to do one step and one step only. So I'm going to take a negative x and I'm going to plug it into all the x values. Okay, so I'm going to substitute in for each of these x values here and here. And a few things are going to happen. But let's take a look what takes place here. If I take negative x and square it, and 4 times negative x and minus 7, what does negative as a quantity x squared become? What does negative x as a quantity squared become? X squared. And then 4 times negative x is negative 4x minus 7. Okay, and you're like, well, big deal, what just happened? Okay, if I had plugged in negative x and done the math, done the arithmetic, and the exact same equation came out, that's defined as an even function. I'll say that one more time. If I had taken x, if I had taken negative x and plugged it in to all my x values, and I come back with the exact same equation, that means it's an even function. Say that okay? Okay, so let me just read you what the book has. Algebraic procedure for determining even and odd functions. Given the function f at x, we have that. Find function at negative x. Am I doing that? And simplify. If the function of x is equal to the function at negative x, meaning it's the exact same function, then the function is even. Okay? So with that information I just gave you, is that an even function? No. Why? Because it's not the same equation. X squared plus 4x minus 7 is not the same thing as x squared minus 4x minus 7. It's close, but this is a negative, where that's a positive, so they're not the exact same function. So right now, we don't have an even function. Okay? Let me read you what it says for the odd function. Find negative f at x, simplify and compare with function of negative x. From step 1, if function of negative x is equal to negative f at x, then f is odd. Wow. Put it in a language we can understand, Mr. Stirrup. This is the best I can present to you. If I take negative x and plug it in, and that was the same thing as taking the whole equation and multiplying by negative 1, then it's not a function. So if I were to plug negative x in like this, and here's my result, and then the other way said, well, what if I take my original function and multiply everything here by negative 1? So if I multiply everything here by negative 1, That's going to give me negative x squared minus 4x plus 7. If these two things are equal, then we have odd functions. Are they equal? No, so we don't have an odd function either. Okay? So, the book says, except for the function f at x is equal to 0, which is a horizontal line, meaning the x-axis, a function cannot be both even and odd. Thus, function at x is not equal to 0. And we can see in step 1 that if function at x is equal to the negative function at x, that it's an even function. We need not to continue. So once you show that it's an even function, you don't have to try and show that it's an odd function. Wow. Can I put a bigger one up on the board? You with me? I promise I won't make you cry too much. You might cry yourself to sleep just one night, not two. Okay, let's see this. I'm going to put this up. This is coming out of the book. Okay. This is something raised to the 7th power. This looks like this. My ends are doing that. And something is going on in between. That's what this function looks like. By just looking at the equation, I cannot tell if it's an even or an odd function. Okay? So, is it neither? Do we know? I don't know that yet either. I know that this is not function at x is equal to 0. How do I know that? Well, 5x squared minus 6x to the third minus 2x is not 0. So, what's my test for even? What should I plug in? Plug what in? I'm sorry? Negative x. So I'm going to take negative x, and I'm going to plug it in. And this, I'm going to tell you, this step, next step is where a lot of students are going to have trouble. You're going to have trouble because you want to shortcut it. Plug it in like this. Plug it in as a grouping. Okay, it's grouped. Okay. If I were to take negative x and multiply it times itself 7 times, so negative x times negative x times negative x, negative x, negative x, negative x, negative x, I know it's going to be x to the 7th, but is it positive or negative x to the 7th? Negative. Are you okay with that? So negative x times negative x is positive x, times another negative x is negative x, times another negative x is positive x, times another negative x is negative, times another positive, times another negative. So this is going to change into 5x to the 7, and there'll be a negative out front. Is that okay? Let's do this next one. So I have negative x, negative x, negative x, which is going to be negative x to the third. So negative x to the third times negative 6 is going to be positive 6x to the third. And then I have, what's going to happen here? Plus 2x. Good. Okay? So if I plug negative x in, and my answer, once I do the arithmetic, is the same as the original, it's going to be an even function. What you're seeing right there is 5x to the 7th minus 6x to the third minus 2x. The same thing as negative 5x to the 7th plus 6x to the third plus 2x. So is it even? No. Okay? Now, in order for me to see if it's an odd function, I think this is the easier of the steps. Okay, so if I want to see if it's an odd function, I'm going to take my original and I'm going to multiply by a negative. And if that is the same as our test for the even, so if this right here is the same as this, it means we're going to have an odd function. Okay, so if I were to take negative, multiply it here, what's this going to become? What's going to happen here? What's going to happen here? Is this the same as this? What do we have? Odd function. Not the worst thing in the world. But you know as well as I, where you're going to get goofed up is right here. When you're plugging stuff in, because you want to do it in your head, you can't make it work in your head the correct way, so you have to go through and talk through the steps. If you talk through the steps, you're going to make the problem work out nicely. Okay? Do we have time to do one more problem? Can I do it? No? You don't want one more? What? Yeah. I'm giving you a hard time, Luke. Grotto over here wants one more. All right. What? No, I'd never make fun of you. The beautiful thing is you think I am. Okay. Can we tell if this is even or odd or neither just by looking at it? You think even? I think you might be right. Because if I already did an odd one, why would I stick an even one up there? Huh? So what's the test for even? We're going to substitute in. I can't spell today. Even. Can't spell any day. So I'm going to take negative x and plug it in. So I get 5 negative x to the 6th power minus 3 times negative x squared minus 7. Still with me? So you remember, if I go through the arithmetic and I get back the exact original, it's an even function. So if I were to take negative x and raise it to the 6th power, which is negative x, negative x, negative x, negative x, negative x, negative x, multiply together, what do I get? Positive. So this becomes 5x to the 6th power. And if I were to take negative x multiplied by negative x, what do I get? Positive x squared. Positive x squared times negative 3 is negative 3x squared. And then I didn't plug anything in here. Is this the same as our original? What kind of function do we have? Even. Do I have to test for odd? We're done. Okay? So, I will tell you this is an even function. If I take negative x, plug it into x squared, I get x squared out. This is an even function. Does this function have symmetry about the x-axis, the y-axis, both of them? Neither of them. Is there, where can I fold it? Can I fold this over? Well, I want symmetry. Is there a line of symmetry? I can fold this over on top of itself. What line am I folding it over on top of? The y-axis. So this is an even function, and even functions have symmetry about the y-axis. Okay? So that's a real basic even function. It has symmetry about the y-axis. You can fold it over, you take the y-axis, fold it over on top of itself, it touches the other side. Let me show you an odd function. If I were to take negative x and plug it in here, I get negative x, negative x, negative x, which because that's y equals negative x to the third, y equals negative x to the third, is the same thing as if I multiply the whole, by the other side by negative. So this function does this. Where's my symmetry? Can I fold it over the y-axis and it matches back up with itself? Can I fold it over the x-axis and it matches up with itself? What would happen if I folded it over the y and then folded it over the x? So if I folded it back over the y, if I fold this back over the y, this is what it looks like. Is that all right? If I fold that then over the x-axis, if I fold this over the x-axis, this is going to come down and give me that. So an odd function is symmetric over the x and y axis combined, as far as the picture goes. Farm Fresh Egg Boy and Cupcake talking about over there. Off task. Alright, so your assignment for this evening is page 163, 1 through 8, 33 through 38, 39 through 47. That's odd, that's all, and that's all. I give you the right one. This is Monday the 15th, yes? Sweet, I gave you the right assignment.
Yeah, 39.
39. Do what? There was a question over here.